No predictions, especially about the future, is advice attributed to physicist Niels Bohr by some and to Mark Twain by others. Will it one day be possible to pass through walls, build spaceships faster than light, read the minds of others, become invisible, move objects with the power of thought, instantaneously transport our bodies across the cosmos? Physicists today tend to consider such milestones as impossible. But could they become feasible in a few hundred years or 10,000 years when our technology is more advanced, or a million years? Answering these questions also means pondering how many unexplored territories we have left in the field of physics, or more generally, the laws of nature. However, much of the future we are envisioning is based on conjectures extrapolated from ideas taken from the present. And it is this type of prediction that invariably misses the mark. Like the Dyson Sphere, for example, now indispensable in every scenario of our distant future, but which, in this video, we want to demonstrate is an absolutely unrealizable fantasy. Not because it contradicts some law of physics, but because it is contrary to any kind of logic. A few years ago, you may recall, the world of astronomy was sent shivers when the young American astronomer Tabitha Boyajian announced that observing KIC 8462852, a star about 50% larger and 1,000 degrees hotter than our Sun, located just under 1,500 light-years away from us in the direction of the Cygnus constellation, she had detected seemingly inexplicable anomalies. Tabby's star, as it was later called, appeared to exhibit unusual and deep dips in brightness at irregular intervals, incompatible even with the transit of a possible planet. The data later showed that the darkening is due to a massive swarm of comets formed for some reason around the star, which, interposing itself in our view, created those deep and irregular darkenings recorded in the light curves obtained by the Kepler Space Telescope. This, at least, is the currently most accredited explanation, but previously another astronomer, Jason Wright, had put forward an alternative hypothesis that around Tabby's star, an alien civilization with highly advanced technologies is building an orbital megastructure capable of capturing, for now partially, radiation emitted by the star and using it for energy purposes. The possibility of creating such gigantic space structures was theorized for the first time in the 1960s by physicist Freeman Dyson. Since then, these hypothetical space veils made of solar panels, so large that they could even render a star invisible from the outside, are called Dyson Spheres. These spheres have been brought up again with insistence, precisely since Wright mentioned them as a more or less plausible hypothesis to explain the sudden brightness dips of Tabby's star. It might be interesting then to reconstruct the history of how the idea of Dyson Spheres was born, starting from the article written over 50 years ago by the English physicist, later naturalized American Freeman Dyson. It all stems from the energy problem. A star like the Sun radiates an immense amount of energy into space, second by second, estimated at about 384 million trillion watts. Where does all this energy go? It's mostly wasted. The planets and moons of the solar system, in fact, turn to the Sun, a surface area much smaller than that of the sphere, that at the distance of each planet and each moon is irradiated by the Sun. The hemisphere of Earth facing the light, for example, intercepts only about 2.2 billionths of the total radiation emitted by the Sun. This enormous waste of energy clashes with the most important need of an intelligent and technologically advanced civilization: to have increasingly more energy to operate and advance societies based on increasingly powerful and complex machines and technological systems. But what would a society much more advanced than ours do to overcome the limited resources of our home planet and fully exploit the most inexhaustible energy of the Sun? Freeman Dyson asked himself precisely this question in an article published in Science on June 3, 1960. His answer was that such an ultra-advanced civilization would have used the mass of the other planets in the solar system to build the gigantic spherical cover. It was the 1960s and everything seemed possible, even disassembling the planets and reassembling them elsewhere, turning them into an immense sphere of solar panels, destined to become an immense and self-sufficient human colony in space. Before moving on, don't forget to subscribe to our channel if you haven't already. Make sure to hit the notification bell so you don't miss out on our daily videos. In general, the Dyson sphere represents a bold theoretical solution to the energy situation that our descendants might have to face in the future. However, with current technologies, it seems entirely impossible to build. It would be difficult, if not impossible, to gather the necessary materials to create the sphere. It would be necessary to destroy and plunder the entire inner solar system, Mercury, Venus, Earth, and Mars, to collect enough material to create a sphere with a radius equal to the Earth-Sun distance, 3 meters thick. Let's try to understand something. In practice, if we can say so, what would the Dyson sphere look like? One possibility is the Dyson shell, which is the most immediate structure to think about, but also the most difficult, if not impossible, to realize. In this case, the sphere is completely closed in on itself and remains stationary, not rotating. The obvious advantage is that all the radiation from the star would be collected without letting any escape. But the disadvantages make its construction truly impervious. First of all, problems of stability would arise during its fabrication. How do you keep a portion of a sphere suspended in a vacuum and always perfectly centered on the sun? Do you know Saturn's rings? Once they were thought to be solid until in 1857, the English physicist James Clerk Maxwell mathematically demonstrated that Saturn's rings could not be formed by a single rigid body. Otherwise, any slight displacement of the center of mass relative to the planet would have caused them to collapse. They're actually made up of a myriad of ice particles, rocks, and dust with diameters ranging from a few millimeters to meters that orbit the planet independently of each other. The surface of the Dyson sphere should maintain a constant distance from the star at every point, but it would be subject to gravitational perturbations from other celestial bodies, such as planets or moons. Additionally, the sphere would need to withstand centrifugal forces and thermal pressures generated by the star. To avoid these issues, active control systems would be required, demanding a significant amount of energy and maintenance. Another common criticism is that the sphere would require an enormous amount of material to be constructed, far exceeding what is available in the solar system. It is estimated that to build a complete Dyson sphere with a radius equal to Earth's orbit, about 600 million Earth-sized planets would be needed. Even if only asteroids or comets were used, it would still take thousands of years to collect and transport them. Furthermore, the creation of the shell would require materials with tensile strengths far surpassing any known material. A final, formidable argument against the sphere can be synthesized into a pointed question. How could a solid sphere of such dimensions escape destruction under the continuous bombardment of asteroids and comets moving towards the sun every year? Certainly a solution may be found, but the mountain to climb becomes increasingly steep. A different and perhaps more feasible architecture is not to create a solid shell, but to send a multitude of satellites equipped with solar panels into solar orbit, achieving what is called a Dyson swarm. There would be no issues with gravity, and the entire structure would be more manageable, being modular. This way, there would be no time constraints on construction, which could last for thousands or even millions of years. Many objects in this swarm would likely also be habitable environments, like a dense cloud of bees buzzing around a beehive. A Dyson swarm would largely obscure the sun from external view, capturing most of the available solar energy. The problem here is that we would have to deal with millions of satellites, not 100 or 1,000. Satellites that would need to be designed to make decisions autonomously to address any minor issue. Not least among them is the problem of chain collisions that could rapidly destroy large portions of the swarm. It should also be considered that a swarm structure would deprive us of the possibility of colonizing the inner surface of the structure, and could have been possible with the solid shell structure. However, it would be less susceptible to the issue of asteroid and comet impacts. All things considered, it appears that Freeman Dyson, although unquestionably a brilliant physicist, indulged a bit too much in his imagination this time. But to be fair, it was the 1960s, an era when almost anything seemed possible. Evidently, Dyson didn't delve into the practical challenges of realizing a megastructure, whose construction would hypothetically occur in the extremely distant future. In fact, he explicitly stated in his published article that his discussion wasn't necessarily tied to future events on Earth, but rather to potential occurrences elsewhere in space. In simpler terms, Dyson's primary interest lay in the quest for intelligent extraterrestrial life. If a Dyson sphere were present in our neighboring universe, its characteristic infrared heat emission would make it easily detectable from great distances. However, up to now, no such observation has been made, implying that highly advanced alien civilizations are either exceedingly rare or the notion of them constructing a Dyson sphere is simply a fanciful tale. In summary, it's fair to say that in our view, the Dyson sphere is a concept that doesn't hold water, both in terms of feasibility and the motivations that would drive humanity to undertake a project spanning thousands of years. And then there's a crucial point. Modern astronomers and scientists seriously considering the Dyson sphere concept resemble those from half a century ago, who predicted that the future would bring us computers the size of cities, capable of storing mere megabytes of data. It would be amusing to show those individuals today a small laptop or even a cell phone, tiny devices capable of storing entire gigabytes. This illustrates a fundamental truth. Technology doesn't grow larger and more complex as it advances. It becomes smaller, more elegant, until it becomes imperceptible or even invisible. Does it truly make sense that a civilization possessing the capability to construct a Dyson sphere, resorting to the destruction of entire planets for materials, would opt for such a cumbersome method to harness a star's energy? Probably not. More likely, that civilization would already possess the capability, let's say, to create small black holes at will, yielding more energy than we could derive from the sun. Similarly, few today would consider that the solution to our energy needs lies in the construction of massive steam engines or colossal water wheels. We are confident that any technological advanced alien civilization would seek economically efficient methods to generate energy, rather than fixating on a somewhat antiquated approach. Nuclear energy is one option, but undoubtedly there could be many other options that our current science has not yet uncovered. All these alternatives would likely be infinitely more economical and scalable than any Dyson sphere, whether partial or complete. In essence, any civilization capable of bearing the colossal cost required to build even a single bend around a modest star would likely have already discovered numerous superior and much more cost-effective ways to generate energy. This in turn suggests that there would be no need to embark on the creation of a Dyson sphere. Hence, it's not the impossibility dedicated by some physical law that would prevent the construction of these unnatural cosmic behemoths, but rather their ponderous impracticability.